Hey, welcome back. We are on lesson 4, the signs, they are changing. This is just transformations of sine and cosine functions. It's on page 791. All right, so we're going to do transformations. We know all about transformations. We've done transformations a lot this year. Remember, when we have a function, we have a lot of different things we could do to that function. We could multiply the outside. We could multiply the inside. We could move the function. We could add the function. We have all these different things we can do to the function, all right? Before we get there, let's do a quick review down here. So when x is pi over 2, let's go look at our unit circle. Our unit circle, pi over 2 is 90 degrees, so that is 0, 1. Remember, cosine is x, sine is y. So sine of pi over 2 is 1. So this is like 2 times 1 or 2. Cosine of pi over 2 is 0. So this is 0 minus 3 or negative 3. These are not that hard, are they? So this is saying the sine of 2 times pi over 2. Well, that is really the same thing as sine of pi. And the sine of pi is right here. And that would be 0. All right? All right, so let's get to the really fun stuff today. We're going to be graphing. All right, so if you recall, what happens when we change the a value of a graph? All right, so we had all these other things. Let's remember we have this function. The new function is a transformation of multiplying some function, or I could have b on the inside. I could translate it with a c, and I could also like add something, right? So right now I'm talking about just this a right here. So what is anything on the outside? Anything on the outside is vertical, right? Remember that? Vertical. And anything that's multiplying is a stretch or a shrink. It's a scaling it. We are dilating it, right? Remember that word, dilating. So I'm going to dilate things, but let's take a look. We understand we're going to multiply by 2 and by 1/2. We'll get to that in a second. Let's verify what we believe we already know. All right, let's verify what we believe we already know by going and checking out a graph. So right here I have the basic sine graph. All right, so that's going to be in red. Now, I have one in blue too. I'm going to change it though. Let's see what happens when that sine graph is multiplied on the outside by 3. Woo! What doesn't change? These intercepts don't change, right? So the period doesn't change. It takes 2 pi, same exact amount of time. Everything is the same except for my max is higher. It's 3 times higher. My min is lower. It's 3 times lower. My amplitude, remember, my amplitude is defined as the distance from that midline all the way up or all the way down, absolute value-wise. My amplitude is higher. Let's try a fraction. 0.25. Well, we're at 1. Is this a fourth of the way? Sure looks like it's a fourth of the way, right? So essentially, what is this doing? This is just taking our graph and changing our amplitude. Our periods are the same. Look, it takes 2 pi. It takes 2 pi for my original and my translated graph, okay? So let's go back and let's graph that. Now we know. So this first one we're going to do in red is 2 sine. That means my amplitude is going to be not at 1, but it's going to be at 2. So I'm going to have a point here. Instead of here, I'm going to have a point down here. Here, it's going to go up here. Here, it's going to go down here. Everything else is the same. So it's going to go through there. My zeros are the same. My x-intercepts are going to be the same. Oh, this is terrible. I'm so sorry. But I think you get the point, right? And it would, of course, go this way, just like that. It would go through, and voila. All right, now let's do 1/2 of that in green. So instead of it being at 1, it's going to be half. So it's going to be here, 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 right? And here. So again, our intercepts are the same. Nothing moved. We didn't translate it. We're just dilating it. Boom, boom. We're just dilating the graph. The amplitudes here are now different, right? In fact, the amplitude right here is 2. All right, so if we go over to page 794, this is like the easiest thing. It wants to know max, min, and amplitude. All right, so max is 2. Min is going to be the opposite of that, negative 2, right? And our amplitude, well, that is our amplitude, 2. So what about these? Max, 1/2. Min, negative 1/2. Amplitude, 1/2. Ooh, cosine. I mean, do you guys think this is the same thing for cosine? There's only one way to find out. Let's go to the graph. All right, so let's change this to cosine of x. There's cosine. Now remember, what's the big difference on cosine and sine? Sine starts at 0, 0. Cosine starts with our amplitude up, 1 up for our basic one. So now we're going to multiply this one. Let's multiply it by 3 or 2. Let's see what happens. Ooh, same thing happens. Our amplitude is just raised up, or our amplitude is just raised down. Everything is the same, whether it's sine or whether it's cosine. Notice again, the period is still 2 pi. That didn't change. All that changed was the amplitude. All right, so let's go back. Now we can do these. Determine the max, min. Well, this is super. This is 1. So the max, 1. The min, negative 1, because it's down 1. The amplitude, 1. Max, 3. Min, negative 3. I go down. And then what's my amplitude? 3. What's my max here? 1/4. What's my min? Negative 1/4. What's my amplitude? 1/4. Remember, amplitude is always going to be positive. Let's say I had this one. Negative 3 sine of x. My max would be 3. My min would be negative 3. My amplitude would be 3 because amplitude is always the absolute value. All right? That is awesome. Great job. All right, now the next one we're going to do this B on the inside. So it's inside. So this B is going to be horizontal, right? Horizontal. So it's opposite of what I think, right? It's still a dilation because I'm multiplying. All right. So now let's talk. If it's horizontal, that means I'm going to stretch it out, right? So maybe it looks like this. I'm stretching it out for somehow. All right. Well, what is that going to change? That is going to change the period. Remember, the period is how long it takes for one cycle of this whole thing. Up, down, out. So this is the normal one is 2 pi, right? So this is going to change the period. That's very important. Changes the period. All right, let's take a look. Here we go. So here's our normal one. Let's get us a new one. Let's do 2. All right, so if I double it, I think that means I'm going to stretch it longer, but it's the opposite, so it's really going to shrink, right? It's going to dilate it, so it's going to shrink. Oh, yeah, let's check. So normally, the red one is the normal one. That is normally 2 pi, right? But now what is 1 period? Now 1 period is 1 pi. All right? Now 1 period is 1 pi. So let's graph that on our graph. All right? I'm just going to copy and paste this because this is way better than anything I could draw. So let's talk about this. So when we have this here, all right? When we have this, we know that it stretches it or dilates it, right? This one actually shrinks it. So now when it was 2, so it was sine of 2x, right? Now it actually made it so that the period is pi instead of 2 pi, right? It actually shrunk it. So it was like whatever I had, and then I divided it by the 2, right? To get me pi. All right. Let's try another one. All right. Let's see what happens when I make it 0.5. 0.5 stretches it out, right? Because I think it shrinks at 0.5, but it actually stretches it out. So now it's actually double that, isn't it? It's actually double that. That's bizarre. So when my b was 1/2, my period was 4 pi, right? Doubled it, so it was kind of like 2 pi divided by 1/2, because when I multiply by the reciprocal, it gives me 4 pi. So that is actually what's happening there, right? So we actually have a formula now we can kind of develop, and if we go over to the next page here, page 797, write an expression to describe the period. Well, the period is going to be as follows. The period is going to equal 2 pi, because that's our basic one, divided by b. Whatever our b is, that is going to be our period. All right? That's awesome. I love that so much. All right. Down here it talks about frequency. Frequency is the inverse, the reciprocal of the period. So the frequency would just be this. Frequency equals b over 2 pi. So whatever I get from my period, I just have to find the reciprocal, okay? Now, before we go on, let's go back here. I want to show you something really cool. I can also find this b another way, all right? This number relates to how many cycles I get through in pi units. So watch. In 2 pi units. In 2 pi units, I get through just half. I get through half of it, right? Look at my red line. In 2 pi units, I get through 1, right? Let's change it. Let's change this to 2. So theoretically, I should get through 2 of these cycles by the time I get to 2 pi. There's 1. There's 2. If I change it to 3, let's look. 1, 2, 3 before I get back. That's an easy way to find that number, isn't it? All right? So it's always good to have a few ways to find things. All right. So down here it says determine the period and frequency of each. So I know b is 3. So I know my formula is for period is 2 pi divided by b. So my period here is just very simply 2 pi over 3. My frequency is going to be the inverse of that, right? So it's going to be 3 over 2 pi. All right, this one. 2 pi over b. Now b is 2/3. I like to multiply by the reciprocal. So 2 pi times 3/2. So that cancels, and I'm left with 3 pi. So that would be my period. My frequency, of course, is just going to be the inverse of that, 1 over 3 pi. All right. The sign here of 1/4, x. All right, so let's see. The period is 2 pi over 1/4. That's the same as 2 pi multiplied by the reciprocal, 4 over 1, which is 8 pi. So the frequency would be 1 over 8 pi. Of these two things, the period is always going to be a lot more important, all right? When we can find the period, it's going to help us figure out how to graph things, all right? And we're going to put this all together at the end, don't you worry. But what I want you to understand is, so far, everything you've done is exactly the same, all right? When I stretch it on the inside, everything, exactly, the dilation on the inside causes it to shrink, all right? A dilation on the outside causes it to, I didn't go on the outside there. Causes it to expand vertically. Very easy, very, very, very easy. All right. All right, so now we're on page 798. We've talked about multiplying them, and that it does exactly like that. It dilates, just like it's dilated in all the other graphs. Let's talk about this C value. Remember C value? That's a horizontal transformation, right? It's a translation, so it's going to move it left or right. Right, and it's the opposite of what I think. All right. Let's talk about this D value. What's that going to do? Same thing. Up or down though, right? And it's exactly what I think. So these two values are what we have left. Let's worry about the C value first. So on the inside, so let's see what happens When I have a sine graph and I add pi over 2, when I add pi over 2, what happens? So what I want you to do is I want you to watch this value right here. Inside, adding means I'm going to go left. So this point should go to the left, pi over 2 units, right here. Let's see if that's what happens. So, plus pi divided by 2. Did all these points go back pi over 2 units? It sure looks like it. All these things, all these red points went back pi over 2 units. Very nice. So let's look at the other one. Let's graph the other one. Let's do this one. Now we're going to take all these points and we're going to add pi to it because it's on the inside. It's the opposite. So this point now is going to start here. This point now is going to start here, right? This point now is going to start here. Missed one. Oh, this point is going to start here, right? Oh, this point is going to start here. So we got, it's going up, it's going down, comes back, all right? We know this point's going to be here. We know this point is going to be here, right? This point is going to be here, pi units away, pi units away, pi units away, pi units away. So we could continue it on like that. All right? Would work exactly the same for cosine. It would work exactly the same for cosine. So let's talk about D. On page 799, it says, what would happen if we had it? So what's going to happen? It should shift up and down, right? And in fact, it should shift that midline up and down. That midline we've been talking about should shift up and down, okay? All right. Well, let's see what happens. All right, let's see what happens. So I'm just going to take the one I have here. So there's my baseline. I'm going to add 2. Boom! What happened? Let's see. 0 to 2. 1 to 3. I'm adding 2. -1 to 1. I just added 2. Everything just adds 2. That's exactly what we thought would happen, right? Our midline is now not at 0, but it's at 2. Boom. In fact, this is going to tell you the equation of the midline, right? And so from now on, you understand sine is going to start on that midline. What would happen if it was cosine? Let's see. Let's change this to cosine. Change this one to cosine. So, on our midline of 2, it actually starts 1 unit, the amplitude above it. Very cool. Very, very, very cool. All right? So, now we have a lot of information at our hands. Let's look at a couple more things. Negatives, right? Multiplying by a negative on the outside. Outside does what? Reflects across the x-axis, right? Multiplying on the inside reflects across the y-axis. So left to right, up to down, whatever, right? Up to down. Let's take a look. See what happens. These are kind of trippy. All right, so let's do cosine. If I have cosine of x and I make it a negative, what happens? It's like a mirror image, right? The amplitude drops, the amplitude goes, it's exactly the mirror image of it. So that's kind of exactly what I would think would happen. Let's see what about sine. Sine's the same thing. So it's a mirror image. So in fact, if you think about it, you're just starting and going the other way, right? instead of starting at 0 going up when I have a positive amplitude, I'm going to start and go down when I have a negative amplitude. All right, so that kind of makes sense. Let's graph those in here. So when I have negative sine, I'm going to start and go down, then up, and then come back, right? And this is a period of 2 pi, right? And cosine, I started at 1, so now I'm going to start at -1. I know I'm going to finish at -1. I know halfway between there, I'm going to be at my highest. Halfway between those, I'm going to cross 0. So I'm going to have here, like this. Same thing, back 2 pi, halfway, like that. Now let's see what happens when we have a negative on the inside. So first, let's do sine. Here is sine and negative sine. Ooh, what happened? Flip looks just like a negative sign, doesn't it? Right? So this is exactly the same as this. So start at 0, go down, finish back at 2 pi. I'm going the other way, finish back at -2 pi. Let's take a look at cosine. Boom! Nothing changes. Why? Because I reflected here? It's already there. It's already a reflection. It's already a reflection. So the cosine of a negative doesn't change anything. That's pretty awesome. All right? Oh, that's terrible. That is terrible. Gotta erase that. Nothing changes. It looks like our normal start at 1, finish at 1, halfway. I'm at my low. Goodness. There we go. Back here. Good. Boom. All right? There you have it. So now we've gone through all of these things and we've proven that it's exactly the same as it was for the other ones. All right, on page 802 it says to write it as a cosine. Now I'm just going to do it one way. So in essence, normally cosines start at 1 and then go down, right? So this shifted over now. I hate that they use these numbers here, but I'm going to tell you that's pi over 2. So it shifted plus pi over 2. So when I write it on the inside, I actually have to say what? Minus pi over 2. So that would shift it over. All right, now I want to come down here to the bottom. I want to graph a few things just so you get used to it. So the first one I'm going to graph is this sine. Now I know this isn't on your thing, but you can sketch it. First thing we need to find, if we have a b term, we need to find our period. All right, if not, we know our period would be 2 pi. So let's take a look at this. Our period is 2 pi divided by that, so it's pi. So I'm going to start at sine. That means I start at 0, 0. My amplitude is -2. That means I'm going to go down. All right, so I only have pi units to work with. So I know that by the time I get to pi, I'll have one complete cycle. Well, remember, one complete cycle. And it's going to look like this time, because I'm going to go down, then up. Halfway between there is going to be at 0. All right, so halfway between here and here is my amplitude of -2. Halfway between here and here is my amplitude of 2, excuse me. So my graph is going to look like this, just like that, and then I would continue doing that. From here to here, it'd be, oh, nope, excuse me, yep, pi, 1 pi, that's right. Halfway is going to cross 0 again. Go low to 2, high to 2, and back, and you could do that over there. All right, let's look at this one. We have an amplitude of 1/2. We have a period of 2 pi because our b is 1. All right, we have a midline at -1.5. All right, so this is -2. This is -1.5 right here. So I know I had to shift my whole graph down. All right, I know from there I'm only going to go up 1/2 and down 1/2. And cosine typically starts above the midline. So I'm going to be above the midline right here, except for I need to do what? I need to shift it. All right, so I'm going to shift that point. From here, I'm going to shift it to the right pi over 2 units, which would be here. I know that 2 pi units later, I'll be back there. I know that pi units halfway, I'll be at my lowest, which is right here. I know that halfway between here and here, I'm going to be at my midline. Just like that. All right. Midline, and I could keep going back this way. Pi units this way, right? And I would graph the exact same thing. All right. All right. So on page 803, I have bookwork for you. Page 803, page 804. I want you to do numbers 1 through 4. All right. Good luck and ask lots of questions.